Good morning, dear students. Welcome back to your online class. Okay. All of you are fine? Yes. Now, so in last class, already we have discussed about the what is matter, what is the constituent of matter, how matter is composed of, okay, and what is the kinetic theory of matter. Means how molecules are arranged in three states of matter. Three states: solid, liquid and gas. And already I have told you in last class what? Some more states newly discovered: plasma, Bose and steam, quartz, crystal and so on. Okay, but here we have to discuss about only three states: solid, liquid and gas. Okay students? Now today we will discuss a new topic. We are aware with a new concept. What? Arrangement of molecules in three states of matter. In last class we have discussed about the molecules of all three states of matter are always in continuous motion according to the kinetic theory of what? Matter. Today we will discuss what? How molecules are arranged in different states: solid, liquid and gas. How? See here, suppose here is a structure of a solid. This circle represents molecule. You know na, molecule is the smallest unit of matter. Okay students? So here molecules are very closely, tightly packed. See here, very tightly, close to each other, very close to each other, very tightly packed. Here it means the intermolecular force of attraction between two molecules is very strong. Is very strong. Intermolecular force of attraction is very strong, and the molecules become very closely packed. The space between the molecules means intermolecular space or very less. Yesterday I have told you intermolecular force of attraction is what? Inversely proportional to the intermolecular space. So if force of attraction is very strong, so intermolecular force of attraction is very strong, then space is very less. Intermolecular space is very less. So due to this tightly packed molecules, solid have different shape and different volume. Like this. See this marker. Solid now. The molecules of this marker means this particular solid very tightly packed. So that's why it is have different shape, cylindrical shape. But if we talk about what? Liquid. And one more thing, solid, it cannot be easily compressed like this. If you want to press it, it will change its shape and size? No, means it cannot be easily compressed. But in case of liquid, the molecules are slightly less, means slightly or less closely packed, less tightly packed, means the space between the molecules as compared to solid is little more. It means what? The intermolecular force of attraction. The intermolecular force of attraction between each two molecules what? Is less as compared to solid. It means here molecules little bit free to move inside the container in a vessel. So that's why it will occupy the shape or size as it contains in a vessel. Same as that contains in a vessel, according to that vessel. So that's why we can see that now what? When we poured or when we just take some liquid in a cup or a bowl, it automatically occupies that shape: cup shape, bowl shape, jug shape, okay, bucket shape. Clear now? Why? Because the molecules are slightly tight packed, okay, less tightly packed. Clear students? And it can be easily compressed as compared to solid. Here intermolecular force of attraction is what? less as compared to solid, and intermolecular space is more large as compared to solid. Okay students, clear? It can be easily flow. Liquid can be easily flow, but it cannot be flow. What? Solid. It have only definite volume, not definite shape. Definite volume, because it can easily occupy the shape of the container or vessel in which it kept. Okay? And in case of gases, what are the arrangement of molecules? Here molecules are totally free, means they are not tightly bound. The molecules are so much far apart. The gap between the molecules, means intermolecular space, is very large, farthest away as compared to solid and liquid. So molecules are totally free to anywhere inside the container and outside the container. Okay students, so that's why the gases molecules or the gases don't have any shape or any particular volume. Okay students, clear? And it can be easily compressed, like when you fill a balloon with air, it becomes inflated, and easily you can compress it. You can easily compress it, and you can just make it join it two surfaces, two faces. What? In case of gases only. Clear students? So in finally we can say that the gases have neither different volume, neither different shape. Liquid have only different volume, nor different shape. But solid have both different shape and different volume due to their molecular arrangement. Clear students? Clear? Okay? And so molecules, how molecules are arranged in case of solid, in case of liquid and gas. It is clear? Okay students? Here very tightly packed. Again I will revise in short. Here molecules are very tightly packed. Intermolecular space very strong. Intermolecular space very less, and intermolecular force very strong. It has different volume, different shape. Here molecules are less tightly packed, slightly free. They can free to move inside the container. Intermolecular space is large as compared to solid, and intermolecular force is less as compared to solid. That's why this arrangement of molecules, it have only different volume. And in case of gases, the molecules are so far apart. There are too much large space between the two molecules. So that's why molecules are free. Okay, they are not prohibited, okay, by any force. They are totally free to move anywhere, inside the container or outside the container. So that's why the gases are easily spread out in over large area. So due to this, the molecular arrangement, okay, what? The intermolecular space very large, and intermolecular force of attraction very less. Clear? So due to this molecular arrangement, gases have neither different volume nor different shape. Okay students? Clear? So go through this video and this topic, and also read the topic through your book. Any doubt you can ask in next class. Students, thank you. Have a nice day.
What the three states of matter are, some examples of each state of matter, the characteristic properties of the three states of matter. The three states of matter are solid, liquid and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed or compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, the properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. so this means the particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed or compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either, but they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons, because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed, they are far apart. As a result, gases are not rigid and can be squashed or compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.